0 dash 2. So in 0 dash 3, what we're going to do is take the answers you got in the homework for yesterday and make them look like what we started with. So in order to do that, we have a couple techniques we're going to use. One of those first techniques is GCF. So in order to use a GCF, it's important to know what is a GCF. So the most basic definition of a GCF is that it is the greatest factor that divides two numbers. Now that we have approached Algebra 2, a GCF's definition can expand upon that. It is the greatest factor that divides two numbers or variables. So again, we're kind of expanding on what we already know and adding to it now in Algebra 2. So to start, it says find the GCF of 9 and 24. So what large number divides both into 9 and 24? It's not really that large. Yeah, thanks. 3. So the GCF of 9 and 24 was 3. So like I said, we're going to expand upon that, and now it includes variables. So the GCF is going to be removing both the common factor. So it's 5. And then you need to remove an x from each. So our GCF is 5x. And then that leaves behind 1x for the front. And 15 divided by 5 is 3. And x divided by x takes it away. So your GCF is 5x. And that leaves behind x plus 3. And again, we should be able to distribute back a GCF and get what we started with. So 5x times x is 5x squared. 5x times 3 is 15x. Just jump a whole bunch of slides. Okay. So next we are going to factor. So factoring, like I said, is FOIL in reverse. So I use a technique, and you don't have to show it, but it's sometimes helpful if the numbers are larger. You're taking the coefficient of the first term, which is 1, times the coefficient of the last term, which is 12. So we get 12. And then you're going to take the value of the middle term, which is 7. And in order to factor this, it's what two numbers multiply to 12 and add to 7. So you need factors of 12 that sum to 7. Anybody beside? All right, Nicholas?
3 and 4.
Perfect. So 3 and 4. So what that makes my answer is x plus 3, x plus 4. And I know this one was simple and you probably didn't need the little magic x in the corner. But like I said, as the problems get more complicated, this little method is going to be helpful. Now, the 3 and the 4 can only replace that at the end when the coefficient on the first term is 1. And you'll see what I mean as we look at a problem or two beyond. So again, first term's coefficient is 1. So you say, okay, what two numbers multiply to 14, but add to -9? So in order to multiply to a positive and add to a negative, both of my numbers this time have to be negative, right? Perfect. So it's x minus 7, x minus 2. Then last easy one. So again, that first term. So what I mean by that first term is that x squared, the number on the x squared is a 1. So two numbers that multiply to negative 24, but add to 2. So this time, the top number is negative. So if the top number is negative, then one of my numbers is negative, and one of my numbers is positive. Alexis? Perfect. So I need a positive 6 and a negative 4. She made the 6 positive because the bottom number was positive. If the bottom number was negative, it would have flip-flopped. So you have x minus 4, x plus 6. We've got x. So what you notice happens in example 5 is the value on that first term is no longer a 1. So now this becomes a little bit trickier. And I told you that today was going to be like yesterday, but in reverse. So yesterday you took a problem and you FOILed it and you got down to an answer that looked like that. So what we're going to do is we're still going to use that magic little x, but now it's not just the 15, it's the 3 times 15. So you get a negative 45. Middle number is still the bottom. Since the top is negative, I have one negative and one positive. So two numbers that multiply to negative 45, but add to 4, right? Perfect. Now, on the last 3 problems, since the a value was 1, those numbers just became the numbers at the end. That does not work now. So what we do is we take these two numbers and we replace the middle term. And you're going to see where I keep going this reverse FOIL in a minute. Be patient. The first one's a little tricky. So we take both of those and we replace this. So you get 3x squared minus 5x plus 9x minus 15. Because again, all we did was replace the 4x with this. Is negative 5x plus 9x positive 4x? So mathematically, have I broken any laws? Is this all true? Is the line I have now the same as the line above it? Yes. This is why we learned the GCF. What we're going to do now is we're going to group the first 2 terms and the last 2 terms, and we're going to take out a GCF. What does 3x squared and negative 5x have in common? Alexis? Yeah, just an x. So you bring out an x, and that leaves 3x minus 5. What can I take out of 9 and 15? Can I take out a 9 and 15, Kayla? Perfect. So you bring out a 3. So once again, that leaves minus 5. If when you take out your GCFs, this and this don't match, you've done it wrong. If these two, what's left in the parentheses, don't match, it's done incorrectly. Now ready? So these two are the same. So that's one of your factors. What's outside is the other factor. Can you see FOIL in reverse? And if not, let's watch this. So our answer was 3x minus 5 and x plus 3. If you look backwards on your work, first, outer, inner, plus. Doesn't this look like the line we used to replace the middle line? This method will work every time for a factorable problem. So you no longer have to use guess and check. So it's the first number times the last number. So 5 times 9. Middle number goes in the bottom. So you need two numbers that multiply to 45 and add to negative 18. If the top number is positive, then either both numbers are positive or both numbers are negative. So in this case, they both have to be negative. What two negative numbers multiply 45 and add 18, Nicholas? Perfect. So remember, we take those two numbers and we replace them in the middle. So you have 5x squared minus 15x minus 3x plus 9. Group the beginning, group the end. Make sure when you group the back end, you group the negative inside, or else it's not going to be done correctly. Okay? Tessa, what can I take out of 5x squared and 15x? Perfect. So you take out a 5x. That leaves you with x minus 3. There's the tricky one. You notice that this is negative right here, right? Is that 9 positive or negative? Positive, right? So I need to bring out a negative number so I can get that negative 3. So if I divide 9 by negative 3, my GCF is a negative 3. That leaves me with x minus 3, and these terms match. So when you see larger numbers, the first thing you want to do is look for a GCF. So do 9, 24, and 16 have a GCF? Does 3 go into 16? Yeah. So it's kind of a trick question. Like I want you to think that way, but it doesn't always work that way. So unfortunately, these are really, really big numbers. Now it says using a special rule. So there is a special rule for this type of problem. What do we know about the number 9 and the number 16? What are those types of numbers? They have a special name. It might even be on your paper. I can't remember at this point. They have a special name. Yep. Yes, they're perfect squares. So if your first term and your last term are perfect squares, what number multiplies by itself to give me 9? It's what's squared. Good, Steven? Yeah. So this is like 3 squared. 16 is good. Thank you, Emily. I was like, can't speak. Okay, so we have 3 squared and 4 squared. What's 3 times 4? So ignore the square. Good, Steven? Yeah. The middle term should always be the first term, so we'll call it a squared. The last term we'll call b squared. The middle term needs to be 2 times ab. So the unsquared version. So in this case, 3 times 4 is 12. 12 times 2 is in fact 24. So this has a special name. It is called a perfect square trinomial. And it will always factor, if it's positive, positive, as a plus b, a plus b. If it was a negative in there, then it could be a minus b, a minus b. It all depends on the sign in front of the 2ab. So that sign could either be positive or negative. So in this case, it's positive. So that means this looks like the 3x plus 4, 3x plus 4. You can also write it as 3x plus 4 squared. Have you seen that before too? You might even have had one of those on your homework last night. And now, I bet if you go back, you forgot to FOIL that, and you wrote the answer as 9x squared plus 16. Because every time somebody sees that squared, they forget to FOIL. They don't rewrite it twice. So if you go back and look before you do tonight's homework, make sure you didn't make that mistake on yesterday's homework. Okay, this is also a special rule. This one is called a difference of squares. And a difference of squares is where you have the first number squared minus a second number squared. So both have to be perfect squares. And then this one factors as one positive and one negative. It does not work if you add 2 perfect squares. It does not work if you add 2 perfect squares. So square root of x squared is x. And square root of 49 is 7. So this becomes x minus 7, x plus 7. Okay, your homework is back in our textbook. So what I'm going to do, since we have like 20 minutes and you guys don't have your books, I'm going to put the textbook page up on the board. So let's pull that book up. So if you've been on Teams and you've looked around in files on Teams under Advanced Algebra 2, I have our textbook. So again, some of you, did anybody in here actually take a textbook? I don't think so. Does anybody in here want a textbook? All right, and as long as you're good with getting it off of Teams, tonight's homework is on page P8. It's 1 to 24. So yesterday's and today's are both due by midnight tomorrow on Fusion Flex.